Hello, I'm Dr. John Prudhont, DBA and MBA in Financial Management and Finance, respectively, an entrepreneur, business finance, and mergers and acquisitions expert. In this video, we will explore basic statistical analysis to help clarify the sometimes murky but extremely important business components of statistical analysis. Hypothesis testing is vitally important in research by bridging the gap between raw data generated by various information gathering methods via statistical sample analysis driven inferences to probability driven answers to related population questions. Hypothesis testing provides a foundational methodology to increase the probability of questions being composed before data is evaluated, and the potential for inferences to be made to data that does not statistically support a predicted question post hoc. Statistics in research provides frameworks of mathematical testing methodology to filter and make sense of frequently voluminous and diverse raw data to most reliably support hypothesis testing to determine if the null hypothesis, this, or alternative hypothesis is valid. The metrics of the central tendency of data elements are the mean, median, and mode. The mean is simply the average of the raw research results, while the median bisects the data, and the mode is the information quantity that appears with the highest frequency unless no data is duplicated. If three or more of the same data quantities occur the most often, then a mode is not considered to be present. Table 1 describes the means, medians, and modes of these study variables of gender of 1.39, 1.00, and 1, age 37.79, 37.00, and 28, education 2.07, 2.00, and 3, personality 5.19, 5.00, and 6, job satisfaction 5.88, 6.0, and 4, engagement 4.62, 5.0, and 5, trust in leader 3.97, 4.00, and 2, motivation 4.42, 5, and 5, and intent to quit job 3.36, 3.00, and 2 respectively. The two components of shape and type of frequency distribution of data are normal distribution or other. Ordinal variables like personality, satisfaction, engagement, trust, motivation, and intent to quit, or rank variables, are not normally distributed due to outliers limiting detection. To determine if a data set is normally distributed, we employed SPSS to conduct tests of normality using the Kolmogorov-Smirnov test and the Shapiro-Wilk test, and a null hypothesis that the data for each variable has a normal distribution and the variable hypothesis that each variable does not have a normal distribution. We use standard 0.05 alpha, a 95% confidence interval, CI, to test the null hypothesis for each variable that the respective variable does not have a normal distribution. The null hypothesis is rejected with all of the variables evaluated by both the Kolmogorov-Smirnov test and the Shapiro-Wilk test, significance values with all values below the significance level showing that they are probably not normally distributed. Dispersion or variability of data elements are standard deviation, variance, range, minimum, and maximum. Standard deviation reflects the original units of measurement and variability of the raw variable. The variance provides overall data mean spread and cluster information with a larger variance indicating a larger spread of data and vice versa. Range is the difference between the maximum and minimum values. Minimum is the lowest and maximum is the highest value for the variable distribution. The shape and types of the data frequency distribution are normal and abnormal. Ordinary variables like personality, satisfaction, engagement, trust, motivation, and intent to quit, or rank variables, are not normally distributed due to outliers limiting detection. Table 3 reflects that to determine if a data set is normally distributed, we employ SPSS to conduct tests of normality using the Kolmogorov-Smirnov test and the Shapiro-Wilk test, with the caveat that if the tests do not return the same significance, then the Shapiro-Wilk calculation is considered to be the more reliable. Using a 0.05 alpha, a 95% confidence interval for the null hypothesis for each variable that the respective variables have normal distributions, the dependent variables return significances between less than 0.001 and 0.002, which are all well below the alpha, reflecting abnormal distribution. Data for a t-test needs to be continuous or ordinal scale. For our study, the independent variable is gender, and the dependent variable candidates for the independent sample t-test are education, personality, job satisfaction, engagement, motivation, and intent to quit. The first step is to use Levene's test for equality of variance, Levene's, to determine if any of the dependent variables violate the assumption of homogeneity, which invalidates SPS's generated significance or probability variable. The 7 null hypotheses in Table 4 are that equal variances are assumed for each of the 7 variables tested. The alternative hypothesis is that equal variances are not assumed for each of the 7 variables tested. If the significance level exceeds 0.05, then the homogeneity of variance is met. Table 4 reflects all variable significance levels listed under Levene's significance column exceed 0.05, allowing us to use the equal variances assumed line for all variables tested except for engagement, which relegates us to use of the equal variances not assumed line. The two-tailed p-score significance column assumes that results greater than 0.05 indicate averages that are statistically significantly different between men's and women's p-scores in the following categories: job satisfaction, engagement, trust in leader, and intent to quit job, with p-scores of less than 0.003, 0.025, 0.001, and 0.043. Table 5 shows that the independent t-test illuminates that women probably have statistically higher education, personality, and intent to quit job than males, while males have statistically higher averages for job satisfaction, engagement, trust in leader, and motivation, with means of 2.10 and 2.03, 5.23 versus 5.11, 5.61 compared to 6.32, 4.50 and 4.79, 3.75 and 4.32, 4.39 and 4.48, and 4.37 and 3.20 respectively. The one-way analysis of variance or ANOVA test was conducted with the categorical variable of job satisfaction and with the following variables: gender, age, education, personality, job satisfaction, engagement, trust in leader, motivation, and intent to quit job. The first null hypothesis is that there is no difference in the gender average across the comparison groups, and the alternative hypothesis is that there is a difference in the gender satisfaction average across the comparison groups. The next null hypothesis is that there is no difference in the age average across the comparison groups, and the alternative hypothesis is that there is a difference in the age average across the comparison groups. The next null hypothesis is that there is no difference in the education mean across the comparison groups, and the alternative hypothesis is that there is a difference in the education average across the comparison groups. The next null hypothesis that there is no difference in the personality average across the comparison groups compares with the alternative hypothesis is that there is a difference in the personality average across the comparison groups. Another null hypothesis is that there is no difference in the engagement average across the comparison groups, and the alternative hypothesis is that there is a difference in the engagement average across the comparison groups. Another null hypothesis is that there is no difference in the trust in leader average across the comparison groups, and the alternative hypothesis is that there is a difference in the trust in leader average across the comparison groups. The next null hypothesis is that there is no difference in the motivation average across the comparison groups, and the alternative hypothesis is that there is a difference in the motivation average across the comparison groups. Another null hypothesis is that there is no difference in the intent to quit job average across the comparison groups, and the alternative hypothesis is that there is a difference in the intent to quit job average across the comparison groups. A standard significance, also referred to as an alpha level or p-value level of 0.05 alpha, was utilized since it is considered an acceptable level for a statistical test. Table 6 reflects the results of the ANOVA and gender's significance level of 0.056, which is larger than the alpha, and shows that the first null hypothesis H0, that there is a statistically significant difference in the gender average across the comparison groups, is accepted, and its alternative hypothesis H1 is rejected. Age's 0.06 significance level is less than the alpha, and the second null hypothesis H20 is rejected, and its corresponding alternative variable H21, that there is a difference in the age average across the comparison groups, is accepted. Education's 0.089 significance level exceeds the alpha, and the third null hypothesis H30 is accepted, and its corresponding alternative variable H31, that there is a difference in the education average across the comparison groups, is rejected. Personality's less than 0.001 significance level is lower than the alpha, and the third null hypothesis H30 is rejected, and its corresponding alternative variable H31, that there is a difference in the personality average across the comparisons group, is accepted. Similarly, engagement's significance level of less than 0.001 is less than the alpha and shows that the next null hypothesis H50, that there is no difference in the engagement average across the comparison groups, is rejected, and its alternative hypothesis H51 is accepted. Trust and Leader returned a significance level of 0.054, accepting the null hypothesis H60 and rejecting the alternative hypothesis H61. Less than 0.001 was generated for motivation, which is less than the alpha, and the null hypothesis H70 is rejected, with the alternative hypothesis H71 accepted. Finally, the significance level of 0.047 is less than the alpha for intent to quit job, and the null hypothesis H80 is rejected, while the alternative hypothesis H81 is accepted. A post hoc test was conducted for the groups that rejected each null hypothesis to determine the reason for the differences using Tukey's post hoc test with SPSS, and the majority of responses failed the alpha by exceeding it for each group. Table 7 illuminates our correlation analysis involving the most probable relationship between three variables: education, engagement, and intent to quit job. The first null hypothesis is that education is statistically significantly correlated with engagement, and the alternative hypothesis is that education is not significantly correlated with engagement. The second null hypothesis is that education is statistically significantly correlated with intent to quit job, and the alternative hypothesis is that education is not significantly correlated with intent to quit job. The third null hypothesis is that engagement is statistically significantly correlated with intent to quit job, and the alternative hypothesis is that engagement is not significantly correlated with intent to quit job. The Pearson chi-square test returned the following correlation coefficients: 0.013, negative 0.001, and negative 0.179 respectively. When the alpha is applied to the correlation coefficient for each pairing, the null hypothesis for the first two null hypotheses are rejected, and the alternative is accepted. The third null hypothesis is accepted, with the alternative hypothesis rejected, and a negative coefficient indicating that the variables move in opposite directions. The value of descriptive statistics tests is that they are used to provide the foundational basic components, measurement levels, and frequencies that we can use as the first step in the statistical analysis process of conversion of raw research-generated sample data into information to determine the most applicable next, more complicated test to perform on the data based on its original configuration and relation to the population. Once the elements of central tendency and variability of each variable is determined using descriptive tests, we can see in Figure 1 that the sample size n equals 504, and determine how the data for the variable of education relates to the center point of the data to determine if normal distribution of the sample is present and if the n size is sufficient to assume extrapolation of normal distribution of the n to the study population, capital N. Since education is a nominal variable, the mode is used, and the median and mean are not included in the evaluation. We can see that with a normal bell curve line applied to the variable of education qualifies for normal distribution status even though the data is skewed to the left. With the determination of normal and other distribution, we can move on to relevant t-tests. A t-test is used to compare a dyad of distinct groups to a progressive dependent variable. Figure 2 shows a t-test where the means of two different groups that compose the variable gender, male and female, and the continuous dependent variable of age are compared. As discussed in slide 6, the next step is to compose a null and alternative hypothesis. In this case, that the groups and the dependent variable exhibit similar homogeneity of variance, H0, and that the groups and the dependent variable do not exhibit similar homogeneity of variance, H1. Levine's test returned a significance level less than alpha of 0.037, which rejects the H0 and confirms the H1, requiring us to move forward with using the equal variances not assumed numbers while reviewing the standard t-test results. The null hypothesis H0 for the t-test is that the group means equal 0, and the alternative hypothesis H1 is that the group means do not equal 0. The t-test two-sided p-value is calculated as 0.289, exceeding the alpha and suggesting that the H0 is true, rejecting the H1, and that the group means are equal to 0. Figure 2 graphically depicts the t-test results for female and age and male and age, and points out where data falls outside of a normal distribution curve but approaches normal distribution with larger ends. The value of the independent samples t-test is that it reveals whether, in this case, female sample gender and age distribution averages are the same as male sample gender and age distribution averages. ANOVA is almost the twin of the t-test. However, it is used and its value lies in ANOVA's ability to test differentiation of an unlimited number of means where t-tests are limited by two group means. We use age and education variables in our ANOVA test with a H0 that all population means are equal and an H1 that at least one population means is different from the others. The ANOVA of less than 0.001 is less than the alpha, rejecting the H0 and accepting the H1 that at least one population means it differs from the others. A Tukey post hoc test revealed that the alpha exceeds all of the significant results, which were between less than 0.001 and 0.015, which shows that all components do not have means of 0. Figure 3 visually demonstrates the differences in means for the three education categories and the mean of age. The value of correlation tests lies in their use to provide a window into the relationship between dyad continuous variables and the direction of movement when an associated variable moves. To exemplify the value of the correlation test, we will use the continuous variables of age and job satisfaction with a Pearson correlation test, Pearson, of the H0 that age is statistically significantly correlated to job satisfaction, and the H1 that age and job satisfaction are not statistically significantly correlated. Figure 4 reflects that the value of the correlation test is demonstrated by the results of the Pearson correlation test returning a two-tailed significance below the alpha, and H0 is rejected, while H1 is accepted that age and job satisfaction are not statistically significantly correlated. The value is increased by Pearson rendering a negative 0.157 score, indicating that the age and job satisfaction variables move in different directions when movements occur. Building a statistical mindset is imperative to accept that multiple tests can and should be done in logical sequences to improve the probability that the raw data originating from a statistical analysis project results in the most probable outcome so that it can be extrapolated and effectively applied to answer real-life business questions. Developing statistical confidence. The fact that very different conclusions can be reached if the most applicable statistical tests are not utilized in sequence to the most appropriate type of distribution, normal or other, and requires the development of statistical confidence through applied analysis of diverse business case data sets. Navigating the various steps of the statistical analysis processes that ensure that the most applicable test is utilized based on a prior test's results can alter the inferred results' potential reliability. Implementation of a statistical mindset and statistical confidence in research and the workplace typically involves the application of new vocabulary and statistical analysis methodologies to scholarly journal research article collections for business finance issues. I'm Dr. John Prudhont, Doctor of Business Administration and Financial Management and Master of Business Administration and Finance, entrepreneur, finance, business administration, and M&A expert. Thank you for taking the time to learn about the importance and application of business statistical analysis. Please contact me at johnprudhont@gmail.com with questions or to book me for speaking engagements and appearances.